Hey guys, welcome to the channel. We've talked about the GSLV Mark III in our previous video. The word GSLV stands for Geostationary Satellite Launch Vehicle. It follows a geostationary orbit. But what is this geostationary orbit? To reach a stable orbit around the Earth, an object needs to reach a velocity of 7.8 km per second. This is normally achieved with the help of rockets launched from Earth. One thing to notice here is that the orbital period of every object varies with the velocity of the orbiting object and also the height above which the object is orbiting. A good example of this is the International Space Station. The International Space Station has an orbital velocity of 7.66 km per second or 27,600 km per hour. It also orbits the Earth 16 times per day and has an orbital altitude of 410 kilometers. Since the space station travels 16 times around the Earth in 24 hours, tracking them continuously is a lot of effort. Multiple ground-based stations and multiple orbiting satellites are used to ensure that the crew of the ISS are safe. To avoid this kind of hindrance, a different type of orbital path is used. It's called the geostationary orbit. The geostationary orbit is a type of orbit where the satellite of the orbiting object is 35,786 kilometers away from the surface of the Earth. At this height, the velocity of the satellite is 3.075 kilometers per second or 11,070 kilometers per hour. The path of the orbit also follows the equator line of the Earth. So an object or satellite in such an orbit will complete one full rotation around the Earth in 24 hours. This is equal to the Earth's rotational period. To a ground observer, the satellite will look motionless in the sky as the orbital period of the satellite and the Earth's rotation match. Most communication and meteorological satellites have a geostationary orbit as they have a larger coverage area over the Earth's surface when compared to satellites on low Earth orbit and medium Earth orbit. This eliminates the need for ground stations to have movable antennas. So Earth-based observers can erect small, cheap, and stationary antennas that are always directed at the satellite. Good examples of geostationary satellites are the INSAT series of satellites and the Gagan satellite. The INSAT, which is an abbreviation for Indian National Satellite System, are a series of multi-purpose satellites launched by ISRO to satisfy the telecommunication, broadcasting, meteorology, and search and rescue operations. The Gagan, which stands for GPS-aided geo-augmented navigation, was used for increasing the navigation of many aircrafts in Indian airspace. Obtaining the equatorial orbit is very difficult as many launch pads are away from the equatorial line of the Earth. For this reason, many geostationary satellites are at a certain offset from the Earth's equator. This type of orbit is called Geosynchronous Orbit. Similar to the geostationary orbit, objects in the geosynchronous orbit also take 24 hours to complete one rotation around the Earth. Well, that's all for today's video, guys. Hope you enjoyed it, and we'll meet again in the next one. Until then, bye.